on function is today. Valerie, welcome. Batty, welcome. Um, Maddie, welcome. Hunter, welcome. So best possible review I could give you guys on function. It is today. Okay, so one of the questions that I get a lot on is what normally teachers will do. They give you a graph and then they ask you a bunch of questions about a function. They can ask you for domain, range, x-intercept, y-intercept, and they want to. They sometimes they ask you if the function is symmetric, if it's not, and they ask you all those questions and. We want to know how to figure this out from a graph, and I'll show you a quick, very, very, very simple way that you can figure all of that out, and also get some more information just by seeing the graph of a function. If you want to see all of this, you gotta go to YouTube to see that, and that's the best way to see it. So now, Kaylee, welcome. So now here's what we have. So they say for the following exercises, use the vertical line test to determine whether each of the given graphs represent a function. So now what we're going to do is what they tell us is, okay, we're going to use the vertical line test to see, first of all, if all of this is a function. Hi, 39, welcome back. So we're going to see, first of all, if all of this is a function, and then after we know that this is a function, what's left to do is just what all we have to do is just complete all of those, finding the domain, the range, the x-intercept, the y-intercept. If you are gonna be taking algebra 1, algebra 2 this year, I guarantee you want to see something like that. Even in calculus or pre-calculus, sometimes they do a review before they they do a review of all of those before they get into the meat of the even. Welcome, Lisa. Welcome. So now, how do we find a domain? First, let's see if this is a function first. So let me use a different color for no reason at all. Let's start with red. So a vertical line test. That means I would draw a vertical line. Oops, nope, that's not what I want to do. I would draw a vertical line here, assuming that this is vertical. And then here, anywhere that I draw this vertical line, it doesn't touch the function in two different spots. So that's what it means. That's what it means to for this graph right here to be a function. So if I draw a vertical line, from up down going through the function, it only touches it in one spot at most. So that we know that this is a function. So that means all of the questions that ask us, we have a way to answer it. So the first question they ask for the domain of the function. Now, when we think about domain, all we want to think about is what are the possible input? What are the possible X values? And I always give you guys the example of, having an oven. What are the possible things that you can put inside an oven that doesn't mess up, that doesn't blow it up or mess up your house. You could put a chicken in there. You could put vegetables, you could put turkey, you could put a bunch of stuff. But now, because we can't really say we can put turkey and list them out that way, there's a way that we can represent them. It's the same thing for numbers. So like in this function right here, we can't say, it can take the value of 5, even though that's possible, and 7 and -5 and -20. We can't list all of them out. We have to find a range, a way to mathematically represent that. So in this example here, because they tell us the function goes all the way up to the left, also, and all the way up to the right. So what happened is it takes all the small, very, very small values, all of them. It can take those negative values, all of them, without any restrictions, and also any positive values. It can also take those without any restrictions. How do we represent that in mathematical terms? So, mathematically, you said the function can go on from -infinity to positive infinity. So A, and I'm going to answer this. So the domain is -infinity to infinity. So that's the domain. So from -infinity to infinity. And that's how you represent the domain. Or you could say the function can take all possible X values. or you could say the domain of the function is all real numbers. So all of those are equivalent. Now let's talk about the range. The range is possible y values, and we go back to the oven example. So what I would say is, what are the output? So when I put the chicken in there, what are possible outputs? You know, you could get cooked chicken, cooked vegetables. You could get, you know, if you put a dough in there, you could come up with bread. You could get a cake. But can you possibly, I mean, there are certain things that are not, you know, that are not possible in the realm of, you know, in the context of you not trying to blow up your house. So there are certain things that are not possible. So, and then these are the output. These are the output that are not possible. In this case here, when you look at this function, you see below here, and I'm going to put a whole wave right here. There's no y value below that axis, below that x-axis. So that means the function, all the values of the function start from the x-axis and it goes all the way up. And how do we represent that mathematically? It starts from the line, you know, y equals 0 all the way up to infinity. So these are the possible y values of the function, and that's how we will represent this. So what we would say is the range of this function is, and let me switch color for no reason at all. Let's go with green. The range of this function is, the range is, and then this was the domain, this is the range, is 0, and I'm going to put 0 here, and then infinity. Now, how do we represent 0? Does the function take the value of 0? So is it possible for the function to take the value of 0? Yes, it is possible. In this case, what here we see here, the function actually touches the x-axis. So that means, what does that mean? So that means the value of 0 is part of the range. So the value of 0 is part of the range. At 1, it touches the x-axis. At -1, it also touches the x-axis. So that means the value of 0 is part of the range. So that means we're going to put a square bracket here. Now, okay, so now we found the domain, we found the range. How did we find the domain? We consider all the possible inputs or all the possible x values of this function. How did we find the range? We consider all the possible y values of the function or the output. Now we're trying to find the x-intercept. Now, what does that mean? It's exactly as it sounds. It sounds like the place where the function intercept the x-axis, and that's it. The place where, hey, good luck on your exam tomorrow, Raven. The place where the function intercept the x-axis. So how do we find that? Oh, we're gonna look at the function. We're gonna see, okay, where does it touches the x-axis? So that's what we call the x-intercept. So now if we go back to the axis, let me change color so you guys understand what I'm doing. So let's say we go back to the axis. You see the function touches here, and it touched the axis here. So it touches the x-axis in 2 different points. So now how do we represent those points? So we could say x, comma, y. Now here's one interesting thing that happened. When the function crosses, welcome Sally. When the function crosses the x-axis, the value of y is equal to 0. And that's vice versa. When the function crosses the, intercept the y-axis, the value of x is equal to 0. So now we say the x-intercept is, I know the value of y is going to be equal to 0. And what's the value of x? So it's intercept the x-axis at this point A. Let's say if I put the point A here, -1, 0. There's also another point where the function crosses the x-axis. This is not the only one. Welcome, Gabby. This is not the only point where the function intercepts the x-axis. There's 2 of them. There is this one right here to the right. Negative, let's call this point a point B, where it crosses the x-axis. We could say value of x is 1 and value of y is 0. Or you could say the intercept at x is equal to -1 and at x is equal to +1. You could write it that way too. So you could write it in any way that you want to. So let's bottom line is, what you want to remember is saying, okay, I look at the value, where does the function crosses the x-axis? And if it crosses it and wherever you find that point, you say, okay, this is the x-intercept. Now, the same thing, similarly, we're going to do the y-axis. Let me see what color I can use here. I feel like I use all of them. Let's go blue. So where does the function crosses the y-axis? Right here, right? So the function crosses the y-axis. That means the value of x is equal to 0. So when the function crosses the y-axis, the value of x is equal to 0. So how do we possibly represent this point right here where the function crosses the y-axis? So here we know it crosses the y-axis at y is equal to 1. What's the value of x is equal to 0. And remember this. So whenever the function crosses the x-axis, the value of y is equal to 0. And that's what we saw here. And whenever the function crosses the y-axis or y-intercept, the value of x is equal to 0. So x is equal to 0, y is equal to 1. This is not an iron. All right, cool. So now let's do something more interesting. So now we want to know where's the function increasing and decreasing. Now let me put this back. Let me put this picture back again so we don't look at nothing messy. All right, cool. So it's a little bit bigger. So we want to know where the function is increasing or decreasing. So what does that mean is, so the function is increasing as I'm, going up and up in value of x, the value of y is all increasing. It's decreasing if I'm going up and up in value of x, but the value of y are decreasing. That means it's decreasing. It's not increasing. So now let's start with increasing, and we're going to do decreasing, and then we're going to do constant. I think that's the order that they ask us in it. Yeah, so increasing. So where is the function increasing? So where is it increasing? Increasing. So how do we find where the function is increasing? I want to know, so where does this happen? As I'm going up and up, or as I'm moving to the right, or I'm going up and up in the value of x, the function is going up and up. So now let's consider. So if I'm starting here from negative infinity here, and I'm going. So as I'm increasing the value of x, the function was here. It start to go here. So that means what happened here? The function is decreasing. The value of y are getting smaller and smaller. So this interval, the function does not increase. Now, what about the next interval? As I'm going to the right, I'm increasing the value of x. What happened in the next interval from negative infinity to, from -1 to 0? What happened? You see the function is going up. Yeah, so that means the function is increasing from the interval of -1 to 0. And that's where it's increasing. Now, let's do the same thing. Let's do the same thing for decreasing. For the rest of the function. From 0 to 1, what does the function do? So as I'm increasing the value of x from 0 to 1, the value of y is, so as I'm increasing the value of x, the value of y, it was right here, it was right here, it was right here. You can see it's going down. So what happened, as I'm increasing the value of x, the value of y is going down. In this interval, it does not increase. So I'm going to show you two intervals where it does not increase. So this interval, it's decreasing actually. Now let's go back in blue. From 1 to infinity, as I'm increasing the value of x, what happened to the function? The value of y is going up and up. So as I'm increasing the value of x, the value of y is going up and up. So what we say in this interval, the function is also increasing. Now, okay, so now if we saw that these two intervals, this is where the function is increasing, and the ones in black, I already told you guys this is where the function is decreasing. So we already answered the next question. Where does the function decrease? So from, where is the function decreasing? So from, and I'll change color for no reason at all. Is the function decreasing from negative infinity in this interval, from negative infinity to -1, it's decreasing. Also from 0 to 1, it's also decreasing. So the value of, as I'm increasing in the value of x, decreasing here, decreasing. So as I'm going up and up in the value of x, the value of y is going to 0. And you can see that too. In this interval here in the black, you see I'm going down. I'm going down. I was right here and I'm going down. So that means the function is decreasing. Same thing here from 0 to 1, I'm going down. So that means the function is decreasing. So now, I found where the function is increasing. I found where it's decreasing. So now how do I find where the function is constant? Constant means, like it's as it sounds, if as I'm increasing, going up and up in the value of x, the function doesn't change at all. The value of y in the function doesn't change at all. That's what it means by the function being constant. Now, how do we find the interval for which the function is constant? Let's see here. Here, there's no interval in which this function is staying level, so that constant. That's what it would means. So what you would see, you would have to see is a part in the graph where the function doesn't go anywhere up or down. It just goes, it just levels out. Now in this example, we don't have anything like that, so that means the function is not constant anywhere. So no intervals for no intervals in which the function is constant. Now let's go back to what they ask us next. So we already answered this: increasing, decreasing, constant. Now we want to know if the function is symmetric about the x-axis or if it's symmetric about the origin. Let's go back to the picture, and I'm going to put it back again somewhere else, another page, so we can answer the last couple questions. Okay, good. So we want to know if the function is symmetric about the x-axis or about the origin. Now, what does it mean by symmetric? Symmetric's about whatever you consider as your if symmetric about a certain position, it's saying that, okay, to the whatever is to the left of that of what I'm talking about. Let's say if I'm saying symmetric about the y-axis, whatever is to the left of y-axis and whatever is to the right of the y-axis, the function looks the same. When I look to the left and to the right, the function looks the same. Same thing if it's symmetric about the x-axis. When I look up, above, or below, the function looks the same. Same thing if it's symmetric about the origin. When I look anywhere, like to the left and to the right, it's going to look the same. So now here's what we're going to do for this one. Where is it? So it's easy to see, right? Let's start with the x-axis. And if we consider the x-axis right here, whatever is here and whatever is here, they don't look the same. Below here, you don't have anything. We already saw that in the range. Above, you have a whole function, so it's not symmetric about the x-axis. Let's make it another one. Let's try something else. So let's consider the y-axis. So if I draw a line here for the y-axis, and if you look, whatever is to the left of the y-axis is the exact replica, and I'm gonna draw this in a different color, is the exact replica of whatever is to the right. Let's do pink. Whatever is to the right. So whatever is to the left, which is in red, and whatever is to the right are exactly the same way. So that means the function is symmetric about the y-axis. Now, what else we need to find? What else we need to find? So another way to look at this, another trick about this is when you find so let's say you have f of 2 is the same thing as f of -2. And if you can see here, if I have, f of 2 here, it gives me this. This is the y value for x of 2. This is the y value for f of -2. So what does that tell us is, no problem, Josie. What does that tell us? The function is symmetric about the y-axis. So f of 2 and f of -2 are exactly the same thing. Now, let's continue. How do we find? So we have I think we have another question. Let's go back to page 8. We have another question. It says if it's symmetric about the y-axis. We already saw that. Now it says whether the function is even or odd. Even function, and I already answered this. That's why that's one of the reasons why I was asking this. I already answered this question, and I'll show you how. Even function means if I have, so let's say for any value of x, that's what even mean. For any value of x, f of x is equal to f of -x. That's what would make a function even. So what does that mean? F of 2 is equal to f of -2. So like, let's say f of 2 is equal to 17, f of negative 2 is also equal to 17. That's even. The function is odd if, that's even. The function is odd if, and we have an odd function if f for any value of x that you consider it, that is part of the domain, f of x is equal to negative f of x. So what f of negative x actually? Negative f of negative x. Or another way to put this is saying f of negative x is equal to negative f of x. That's another way to put this. That's probably a less confusing way to put it. Negative f of x. So what does that mean? If I consider a value of x, if I run that value of x through the function, so f of x, and then f, let's say if I consider a value of x, f of x, f of negative x is equal to the negative of f of x. So what does that mean? Is f of 2 is equal to 5, f of negative 2 is equal to negative 5. So in this case, this is not what we have. So this is not what we have. So this function is not odd, but we have this here on the side because f of negative 2 is equal to f of 2. So that's all. So that means this function here is even. It's an even function. It's not an odd function. It's an even function. And that's all. Let me see if you guys have any questions. Yeah, that's all I wanted to do for this one. So first, we started by finding the domain of the function, and how did we find a domain? We consider all the values for which the function is, all the values of x, possible value of x that you can plug in inside a function. In this case, what we saw is for any value of x, this function exists, and that means the domain is all possible real numbers, or you could say negative infinity to infinity. The range we said, okay, what are the possible outputs? So when I put all those value of x inside of this function, what are the possible output? And with the way this function set up is, you see below the x-axis, the function doesn't really exist below the x-axis. And above that, this is where you have a function going all the way up to infinity. So what we say is this function is the range of this function is 0 all the way up to infinity, including the value of 0, because the function the graph touches the x-axis. Now, for x-intercept, and we remember this trick that we say in x-intercept, the value of y is equal to 0. So how did we find the x-intercept in this function? To find the x-intercept, we look at the function and see exactly where the function crosses the x-axis, and that's how we found the x-intercept. Same thing for y-intercept. We'll look at the function and see where the function crosses the y-axis, and then to find where the function is increasing, as you guys remember, it's saying, okay, when I'm going from left to right, and at each interval, what is the function doing? So in this case, from negative infinity to negative 1, the function is going down. And from negative 1 to 0, the function is going up. And from 0 to 1, it's going down again. And then from 1 to infinity, it's going up. And then we said, okay, it's decreasing, increasing, decreasing, increasing. And that's how we found the intervals. We also found that this function is not constant, because every time I have a value, the function doesn't level out anywhere in this interval. So for each, the function doesn't level out anywhere in this interval. Now, what else? It depends on the polynomial, Priscilla. It depends. If it's a quadratic, you could use the quadratic formula. So it depends on the polynomial. So if you want to, you could factor it too. You could factor it and find the roots and stuff. It depends. You would have to see which one, how it's set up. Yeah. So what else we did? Yeah, we found that the function is not symmetric about so we were trying to see if it's symmetric about the x-axis and y-axis, or about the origin. So the function, what we found is the function is symmetric about the y-axis, because when you consider the y-axis, everything to the left of the y-axis looks exactly the same as everything to the right. And then the other thing that we found is the function is even. Another trick that you guys might know is if the function is if the function is even, and I showed you that, to find if the function is even, you said f of negative x is the same thing as f of x. And that's it. That's all we did for this one. And okay, so to know if the function is odd or even, and so here's how we do it. Here's how we did it. So if I want to know if a function is odd, where am I? So if I want to know, let's go back again for Josie. Josie, if I want to know if the function is odd, let me put the picture back again. So I have this function right here. If I want to know if it's odd or even, the formula, mathematically, this is the way that you represent this. So mathematically, you said the function is even if I have a value of x, f of x is the same thing as f of negative x. So what does that mean? F of 2 is the same thing as f of negative 2. And that's for all value of x. F of 3 is the same thing as f of negative 3. For any value of x, f of 17 is the same thing as f of negative 17. That means the function is even. So in this case, f of 2 here, it goes right here. F of negative 2 goes right here, 5, right? F of 2 is equal to, man, it's close to 5. It's somewhere close to 5. F of negative 2 is the same thing. F of 1 and f of negative 1, both are associated to a y value of 0. F of 1.5 is here. F of negative 1.5 is here. So from this function, all you see is f of whatever number you have is the same thing of f of the opposite of that number. So it's the same thing of f of negative of that number. That's what I meant. And that means the function is even. That's all. And that's the case for any value of x. Whatever value of x you put in inside this function is the same thing as f of, for that specific value, f of whatever value that you put in is this exact same thing of f of negative that value. So not confuse you. The two things you could see, you could look at, you can look at the graph and see if it's symmetric about the y-axis. I mean, it's going to be, an even. And also you look at, saying that, okay, so if the function is symmetric about the y-axis, so what's going to happen is for every, whatever is to the left of the y-axis and whatever is to the right of the y-axis, this is going to be identical. So that means f of is the same thing as saying that if I calculate the f of everything that's on the left is the same thing as, when you consider the y-axis, f of the output for every x values that's on the right. So let me explain this in a different way so that I don't confuse you. So if the function is symmetric about the y-axis, what does that mean by being symmetric about the y-axis? It means to the right of the y-axis and to the left of the y-axis, I'm going to have the exact same thing. So that means what's to the left of the y-axis? The negative numbers. For those negative numbers, the y values are going to be the exact same thing for those positive numbers. I hope I don't confuse you. And mathematically, the way you represent that is saying that for any value of x, f of negative x is equal to f of x. That's for even function. For odd function, if the function is odd, so all you have to say is almost the exact opposite of what we just said. So if the function is odd, it's an odd function, f of negative x is equal to negative f of x. So what does that mean? So if I consider the value of 3, f of 3, or f of negative 3, for example, is going to equal to negative f of 3. So let's say f of 3 is 207. F of negative 3 is negative 207. If that makes any sense. Josie, let me know if you understand what I just explained to you. I think, guys, I think this is it. So I wanted to show you guys how to do those because I have this question. You're gonna see it if you're ever taking algebra 2, pre-calculus, calculus, and yeah, you're gonna see this question a lot, and that's why I wanted to go. Okay, yeah, I'm glad you understand. I'm glad that makes sense. Okay, guys, and I think this is it for me for today, and I will catch you all another time, and I appreciate you coming by. If you want to see the replay, go to YouTube and type the Jax tutor. It should be up automatically. I don't do anything to it, so I just let it go in there. So if I messed up, you'll see and tell me next time. Yeah, that's it, guys. Thank you. Thanks for coming by. Thank you. Bye.